Good afternoon. We're going to do one more hour of this, but not really the full hour. We're going to end at we're going to do 1 hour, 1:40, 13:40. Hello. I guess we're going to talk about perfection, but not really perfection. We're going to talk about discernment, how to discern perfection. As Richard Feynman said, you will observe that your fellow countrymen, your fellow man, will naturally, in the honest pursuit of truth and knowledge and work, they will solve things to the best of their abilities, which is quite true. I have observed that indeed as well, the truth of this world. What I'm trying to say for you is that what I constructed right here, this formalism is basically saying, like, we have some trajectory of conversation, R prime. We have some distance, which is like whatever. I'm tired, but I also see when I'm tired, when I give up, when I die, we all die. I kill all of you guys. Time within each other and within ourselves. What I'm going to say right here is that when we discuss the formalism of emotion, of hubris, so to speak, when someone says that there's trivial, we're going to live on in AI. Well, no, potentially no, but that's only because of the rapid changing states of your brain. That would be hard to be simulated accurately. Unfortunately, that would not work. So what I'm trying to say is that the last time we discovered the formalism, we wrote the formalism of momentum being related to our emotions. So just so I can rederive it and show the new audience, we said, and I'm trying to describe this gap right here. Let me grab the purple. I'm trying to explain how this gap right here is equal to the hubris, the average hubris that someone might have. So this is going to be delta t is that physical distance, and their direction is going to be along the plane of average. So along the plane of average, where radius r equals 0 is average, we said that there may be someone at some trajectory r double prime. And r double prime is flat into the plane. You're trying to explain an idea out here in r prime. So they're trying to say that their r double prime thought, which can be converted to just a radius direction because they're very trivial, r double prime. So we're going to get into vector calculus. R double prime can be normalized by this formalism, r double prime divided by r double prime normalized. So the point is, we're just trying to write something that has the vector direction, so r hat of double prime that has some unit length 1. And so they're trying to say that their little bit of time, little bit of delta t right here, that they spent thinking about the counter to what you were trying to explain, they're basically saying like, oh, but my thought though, my counter argument though, my counter argument is just so valid since it's just a projection onto yours. So they're like, oh, but I already saw your unit vector direction. I saw the direction of travel, and they're just going to ignore it. So r double prime pretty much equates to the people who did not hear the entire entropic process that we described earlier. A clear black night, a clear white moon. Warren G's on the stripes to consume. Yes, I gotta stop being tired. I gotta do this one more time. Is he talking about Minecraft? Finally, a show in physics. Yeah. Is this one of those trans debates? Lamau, you guys are all funny. False. Is it possible with the advancement in technology to upload consciousness into a robotic symbiote? Potentially a symbiote that has robotic synapses? Potentially, that would actually enable a simulation of your mind. Would it be reliable simulation? That's a worry. We don't know if the symbiote, by using how to, okay, I'll show you real quick about how that could work. This is gonna be your live. You present questions and we're gonna talk about it in terms of information theory about what we could do. This is the emotional and the conversational cone of reality, a structure of reality. We already discussed it in the last live. I'm gonna upload it in like a day or two, probably Monday. I doubt consciousness can be a robot. Not accurate full simulation, but the sad thing is that it's getting a lot closer than you think. You may press X to doubt, but your doubts are just a button. Your doubts are just a synaptic input, so they're worthless, is what I'm saying. You may press X to doubt that as consciousness can be sent into the robot, but we're already seeing robots that biologists are saying they're just robots, but they're not. They actually have the synaptic resources that could simulate consciousness, and they do simulate consciousness, because consciousness is just these waveforms we're going to discuss. Okay, we're going to talk about the horrors of growing brains in a vat and brain organelles in a vat, because I think it's unethical, but not because preservation of life and stuff. More so that consciousness really is just the exchange of neurons. It's the exchange of information. You can encode information very well with just 128. I'm going to show you real quick how we can make an actual consciousness the same way they have, and it's a lot more dangerous and sad than you think if you do it the way they did. So we're going to explain how this works. We're going to say that we have 128 vector, so 128, and this represents all the different neurons that could be firing and their state of firing. What they have is they have brain organelles, so like these organelles, and they have some internetting structure. And the crazy thing is, even if you only, this is literally machine learning, even if you only give it 8 possible inputs, where it can all you need is a small substructure of inputs. So I'm trying to say that you could theoretically upload your brain. Suppose we actually could recreate, we could store all the states that your brain was. Suppose we only need 50,000 and then whatever, 50,088, whatever. So the point is, if you had some organelle that had the ability to send inputs that could manipulate these 50,000 neurons, what really happens is that every time you send an information or a signal, you really send it in this form, the information theory form. You send it in the form of an up and an anti-down. The anti-down is the recourse, is the thing that happens back to you, and then the up is the signal you're trying to send is the cascade. The anti-down is also your perception of this signal. So when it's like, I want to move that Tetris piece or that Pong piece, because they've had organelles play Pong. So the brain is going to say, I want this, I want the U. And then it's going to look at what the anti-down was. It's going to look at what was the recourse, what happened. However, as you can see, it's not just a single one-to-one change. When it's a single one-to-one change, you know what's going on. Basically saying, I got what I wanted, I moved to Pong bar. So if we sent the input, move Pong bar up, effectively in the organelle's consciousness, whatever it is, it sent the impulse of whatever it takes, the U part, to get my reaction of this thing going up. So this U part, in terms of machine learning, could be the collection of brain neurons that then goes to the computer to then tell the Pong bar to go up. The brain thinks to itself, I only want this causality. So theoretically, if we wanted to simulate consciousness, we don't need too many input neurons. We don't need too many. But you do need a very good and changing network of, this is your neural network. The neural network is the vector part, is not the input part, which is part of machine learning. It's not the input, it's the stored vector. That's the neural network. It's your weights and balances. Pretty cool. Okay. We should get you a Bluetooth lavalier microphone. I should actually. I'll buy that. Okay, thank you. I should. It will have to choose right from wrong without programming. It would. I doubt consciousness can be in a robot because it would have to choose right from wrong without programming. I mean, theoretically, if we just captured your thoughts on your ethics, that's your vector right here. It wouldn't have the ability to choose right from wrong. It would choose whatever it wants to choose of these inputs. This is your memory. This is your stored consciousness. So you're probably right that it would probably fire randomly on these things, and it'd be like, oh, I can get these outputs, and it would manipulate the heck out of what it knows to do. So, what is the ethics of putting an organelle, some random biological input mechanism into some thing? We don't know what it's gonna do. So it's almost like being born with tons of information. That's weird. What would happen? What would happen? That'd be so cool. But part of biology is that it has a feedback loop. So like if it doesn't like something, like that random input my brain sent, my organelle brain sent, it damaged me, it hurt me, and I felt the pain receptors that then came back to me, it would tweak the weights and balances. So it's pretty cool. We can get approximately close. We can get pretty close, but it follows this form. It's just how much cascade occurs after you send your trigger, after you trigger that neuron. That's the cool part. Biology tweaks these values right here. Now we gotta stop using, man. I'm really not interested. I'm not interested because partly of the antagonistic other. I'm way too familiar with the way conversations are disregarded, where it's like, oh, well, you're not actively working on the problem. Well, like, I wish I could. You know, if we had UBI and I was allowed to work on whatever project I'd work on, I'd work on the organelle problem. Because I basically say, like, we could integrate circuit boards, and I think that'd probably be the way for us to do it ethically. Give it a circuit board that it can tweak these pretty much, it can use less neurons on its own side, it can tweak electrical values, and it can cause output. But we don't want to use the organelle itself as the computer chip. That's just lazy programming, lazy design. I think it's unethical to use the organelle itself as the computation device. I think the organelle should be doing pretty much like the processor. It should be making decisions, which is kind of freaky, but we could make that possible. Where basically you make the right decisions, you get fed. If you make the wrong decisions, you don't get fed. So the organelle dies. That's sort of our safety mechanism, how we can prevent these things from doing unethical things, where it's like, oh, but I think that's fun. I think it's fun to get like some other reaction that we didn't want it to do. So in order to control these organelles, we should do it in an ethical way that isn't, too evil, That's why if you're going to be messing with brain-grown organelles, you got to be very careful with them. I'm working on universal inheritance with forgiveness-based. Then there is the emotion, love, hate, anger, and a reason to live. And that's part of it. Yes, there could be sub-processes going on inside these organelles, like based off their internal hormonal chemistry, like adrenaline and stuff like that. But I should read more into the papers. And you're probably going to bring up a very good point. Maybe these brain organelles don't produce adrenaline, don't produce those other higher order emotional behavior chemicals. And if it doesn't produce the chemicals that could cause behavior, then theoretically, what are they? What are they processing then? How does it feel to process information without hormones? That's interesting. Also, you would have to have a strong research background in how hormones affect neural pathways. We know how they affect neural growth and neural development by hindering them in terms of stressors and hindering them in terms of exciting development in terms of adrenaline, which is pretty cool. which makes sense. Like if you're in a very intense emotional state, you don't want the body, it's unhealthy for the body. So now the brain has to be like, well, I know it's unhealthy for me to be in that state all the time, so I should learn whatever I need to from that problem so that if I ever have to do that again, I can get out of that emotional adrenaline state as soon as possible. So if you learn that the best way to break your adrenaline is to just beat the heck out of someone, then you're probably going to do that pattern of behavior the next time you become in that adrenaline state in a similar situation. You learn much faster in adrenaline. You learn slower in stressful environments. So it's very fascinating, and you need adequate sleep. So it's a lot of issues about the brain that are complex but solvable, which I think is beautiful about this world. Man, my emotions are drained. I dealt with adrenaline, so to speak. I don't know the exact chemicals right now because I don't think it was adrenaline, but maybe it was. It was just endorphins of like that more aggressive conversation I had earlier. More emotion filled. I'm tired. Dune Goon. What a wonderful name. I love that. I want to talk about emotions and more about mirror metaphors like the live description is about. So ask me questions and stuff like that. What do you make of the new fully formed galaxies that suggest a universe beyond 13.8 billion years? What I think that they suggest is pretty much that the universe is a lot farther than we think. And here's the weird thing. Maybe we didn't have a big bang. Maybe we had a consolidating universe. So like it would help give evidence to that. That maybe we didn't have a big bang. Maybe we just had a universe that cooled, so to speak, congealed together from a very high energy state. It congealed into a lower energy state. It would suggest that. I can send you coherent tuning fork energy to help calm you. Whatever you believe in, brother, whatever you believe in. For me, the tuning fork for the brain is music. And I'm listening to Nobody Home by Pink Floyd. I think perhaps I should stop talking about professionalism. I should stop talking about work, so to speak, because all this stuff to me is work. And I do have second sight, but I have no one to share it with. And that is a lamentation of this world. I've always wanted to be able to do this stuff that I just explained to you guys an hour earlier, but for my fellow man. I wanted to show my friends how I could solve problems, how we can stop suffering in our own world. Where it's like, oh, do you feel hungry? Sorry. My nose is getting clogged. Do you feel hungry? Do you feel sad? Do you feel sick? Well, I know how to solve it, man. Let's just look at it. Let's look at the problem together. We can come back to each other. We can return to a peaceful moment. And I used to love to playing games with the friends and stuff, but now I feel guilt, or at least I used to. I feel guilt every time I don't do the work, so to speak. So now that I'm here, now that I've already done the work, my body is telling me I'm tired. My body is telling me, yeah, you can go back to being sad again because you explained your concept to other people and they still didn't get it. There's still nobody home. And that's part of what I wanted to talk about today, that music encodes our reality. It encodes emotional pathways that have been felt before, that will be felt again. And I call it the garden of thought, the garden of reality. Where do you want to go, my friend, my love, my brother in Christ, whenever? I don't care, because I just want to be with you in the moment. And I got nowhere to fly to, because I can enjoy my world. I can drink whatever I want. I can go fly planes, but it's expensive, but I can do it because I love it. I love it. But it's and then there's nothing to do. And then it's we're all going to die again. We're all going to, people are just going to ignore each other and disregard each other, disregard the lessons in music, the love for their fellow man, and they're just going to let each other go away without ever caring about each other. And then now that I took my break, I have to go back to aggression, because that is how we fight death. Forgot about Dre. Everybody forgot about Dre. All right, I'll get to there. Let me read your comment first. Or perhaps the Big Bang happened, but 80 billion years ago. Exactly. So, I always thought, because based on the data, it seems like what we can see simply happens to be what our photoreceptors can detect, or our phototechnology. That's what I mean, photoreceptors, not photoreceptors of our eyes. Photoreceptors of our devices could detect. And it sort of confirmed that, where it's like, dang, the universe just keeps going as far as we can see. So it's like, or here's another thing that theoretically could be. The very distant galaxies, if there was a Big Bang, could be that there is a starting point to the universe. It's basically saying, in this direction, we saw some early formed galaxies, but for some reason in the other direction, we saw some as well. So, that's the thing that sucks about astronomical papers. As far as I've seen, it's very hard. They don't really explain too much about where they're scanning in the sky. I think every astronomical paper should begin with the arc coordinate system relative to something, just so we can at least identify where we're looking at and where the studies are. Good evening, everyone, or good afternoon, everyone. What if the universe is one giant being, and Earth and all the other suns and planets are like its cells? I have evaluated that. Information is like a cell in terms of, not like a cell, but it's like a neuron. So what if the universe is one giant being, and Earth and all the other suns and planets are like its cells? I think what's more likely is that everything in the universe. So we can explain things gravitationally still with the standard model if we break it into its fundamental form. So we have some orbit, some planet, some sun, obviously not to scale. I tried breaking this apart and it worked. So we have some orbit and we have some stored momentum and velocity. That's the anti-d. These things sort of match, and if you start building an actual orbital system, they sort of match the information content within a molecule. So I think what's more likely is that it's the information of stability, of chemistry, that everything matches. I don't know what molecule, because it could depend on how many objects it has, and then locally this thing might have 3 different planets, but how their orbits are bound in stability really actually depend on a finite amount of rules. The triple body system, they have to be at least some phase away from each other, and we can store that informationally. So that, all right, they have to have this phi, this difference in orbital period from each other. We can store that as a W plus or a certain type of reaction, and you can start seeing how our universe is just a set of these chains. So in terms of the bigger planetary structure, it's this, and then you can start seeing how they have interactions between each other that are just these exchanges of information. I'm not saying that it's arbitrarily simple. It's not. I'm saying that everything with stability will have some form of that's why it's stable. So, conditions. It's a conditional universe. You can describe the conditions in a state form. That's all I'm trying to say. So the universe follows the fundamental information of the standard model, which is cool at all levels. So, is our universe like a cell? No, it's not biological. It's more chemical, which is fascinating. The universe is the concept of nothing is impossible. Therefore, we exist only here and now. We dealt with that. Okay. Comfortably Numb by Pink Floyd. Indeed. If people believe that there's only the here and now, okay. yes, you're right that there is only the here and now, but it goes a little bit deeper and a little more, not esoteric, but a little more like, yes, there's only the here and now. So that's, once again, the scalar field, or what could be. Okay. We're going to now define this as the plane of time. And the plane of time moves forward 1 second per second squared. It doesn't matter how, what this unit is. It really doesn't matter. All we're trying to say is that stuff is always moving in front of you. So informationally, the conversation we have is just bits, like transition of bits. So I talk about this thing, and then the plane of time goes along. I talk about the next topic. The plane of time goes along. Now we reach T0. I talk about this topic. And so if I want to talk about anything, then it requires me to have a trajectory, a planned trajectory through space. So if I want to get to some r prime, then I have to talk about these bit values in their specific manner, in their specific correct trajectory, so to speak. Yes, you are always dying. The only thing in front of you is the moment. And theoretically, because the only thing in front of you is the moment, if you don't practice this dual mirror, where you can listen to a song and basically be transported to its emotional content, so then you now have a new starting point. Without that starting point of music, we could never get there, because we would have to start at R0 every single time. And R0 is depression, is isolation, it's the average thought of nothing. It's nothing. So yes, you're right. There is nothing. And that's a sadness of this world. We always have nothing. And in order for us to converse, we either fight and we build that ourselves from nothing, or we listen to music and we build from there. You listen to the previous conversation and you transcend that distance, that it really is distance. Distance is equal to delta E, delta T. At least stored energy for so energy in this case just means the bit values in order for us to reach that point of the conversation. It's radius r. So that's all we're saying, from the average cone of 0. So the average cone of 0, we ignore that. We're not trying to be average. We're trying to live. And how do we live? Well, we sort of ignore the counter, the antagonistic other. Because why would you invite someone who's trying to drag your vector direction over there into some meaningless territory, being like, you're annoying, you're wrong. Okay, brother, all it is that ever could be and ever will be, and you're deciding to be negative, go ahead. Damn, and it's funny, I like what I'm looking at right now. It looks like I'm in a wheelchair where it's like, ee. So the moment in front of you, that's what that means. Yes, you're right, there's only delta E, delta T. But it's how you deal with it, how you live it. So I'll leave that. Because why stare at a blank, empty screen when we can have conversations and have something to look at? Okay. No, dog, that's not what I mean. Fish can only exist in the water. Okay, I like what you're talking about. You seem like you're... Okay, I don't disregard you. I really don't. I was just trying to talk about the general antagonistic other. We're going to get to something. We're going to get to because your comments are meaningful. Is it possible that the CP violations is done for a reason? So you're talking about charge parity and not charge parity time. The reason why charge parity wasn't a fundamental symmetry was because time was actually a real construct. That is why you need both charge parity and time in order to have a consistent basis. So CPT violations, are they done for a reason? Yes, that just means that's the informational content of the standard model. So every time we discover these things, hey, well, that's not perfect, that got us to the content of information that enabled me to then basically say, hey, this is that one thing I think you guys are overlooking. And so that's all we are. That's all we're doing right now. No, dog, that's not what I mean. Fictionally, it's the anthropic theory bubble nuts. I agree about the anthropic principle. Like, yeah, we're supposed to acknowledge that we could be in any universe, any possible universe, and that's why we're in a binary universe, just because it happened to be the most likely possibility. But it also is fundamental, so we're very close. Dude thinks he interpreted my words correctly, and then going on this long, pointless tangent. Well, I guess you proved my point right there, where there are people who talk about our negative prime, our double prime, pretty much, so to speak, a different vector direction, and then they presume you to be in the incorrect basis or wasting time. The universe has an event horizon. Outside of that, there is another universe. How can you say that? By event horizon, you mean outside barrier. What we're saying, or at least what the other guy asked, is that the universe, how do you explain the very distant galaxies that are formed as visible in the new James Webb Deep Space Telescope? How do we explain those that are very far, that are technically too old or too mature for the age of the current predicted universe? So if there was an event horizon, it seems like that is not the case. It seems like there's an informational horizon, yes, but we're not there yet. There's more information to be collected. And the event horizon in what you're trying to say is, you're not right, because you, in your current context, have been proven wrong based on how there's more data. As we predicted, there should be more data because it's just very, very infrared. So we need better infrared detectors, which we're getting there. Let's assume the universe has a greater cause than a proton has a reason. Let the universe assume the universe has a greater cause than a proton has a reason beyond the normal existence. Protons only exist because of the rules of stability, which is the rules of the Standard Model. The universe only needs the rules of binary to exist, and that is encoded in the Standard Model. So what's fascinating is that the universe itself happens to exist, and it does. But like, I'm not saying that in an orthotic principle way. I'm saying that in as far as fundamental information theory suggests, binary information theory, like, you don't need anything else. There is no, I can't say that here, which is funny. I think there's someone. Wayne Bain, no one knows anything for sure. You don't even know if that's true. Eli H. Who's okay? And the Standard Model is not about Naomi Campbell or Cindy Crawford. Well, that's right. Kind of random. Do you have any thoughts regarding ADS, CFT, and Plato's Cave? But anyone that tells you, okay, Plato's Cave, very much, yes. A lot of this technically is related to Plato's Cave, which is kind of sad. So, pretty much the orbits, like we just talked about, right? What I talked about right now, how the orbits themselves technically are encoded states, stored states, which makes sense. They're conditional states. Does that mean you can solve the orbital mechanics with just particle physics alone? No, I'm saying that you can store the fact that they are orbiting and at those conditions as a simplified state. And that simplified state basically then says you will observe this stability, this orbit can exist because it has these informational pathways, these informational patterns. So it's pretty cool. It basically lets you store indexes or categories of things, but it doesn't explain why those things or how those things are transforming. It only does discrete things, whether it is in orbit, whether it's not in orbit, stuff like that. So it's pretty cool. So it's used for discrete objects, not continuous objects, which is pretty cool. So we'll talk about Plato's Cave a little bit about that. And what I'm trying to say is that if you don't, so the reason why we couldn't do any of this stuff before is because we didn't have the Standard Model. We didn't have the vast amounts of data that lets us build information theory, lets us understand things as fundamental, not just as opinion. So Plato's Cave existed, or it's still a very great philosophical idea. It's probably one of the most rigorous ideas that could ever exist. All it says is that if you never knew more advanced theory or more advanced concepts of the world, then you would think that the shadows on the wall is all that ever was and ever would and ever could be. The thing is, a lot of people think that they're out of the cave. They think they know everything that the universe could be. And even if they say, I acknowledge I could be in the cave right now, when you show them information theory of the Standard Model, they're like, so you're saying, and then even then, you might get some people that say, oh, so you're saying as above, so below is correct. Just like the last live that 2 lives ago that I was talking about, how everything matches the Standard Model. It's more like as below, as the fundamental is above. As the fundamental is above. That's the truth of the world. Not as above, so below. Not orbital mechanics, not the stars tell us about here on Earth. Not at all. The macroscopic does not escape the microscopic, but the microscopic does explain the macro, which is pretty cool, which is good. It shows that fundamental objects do exist. Plato's cave just says that you might still be in the cave, but we are pretty certain that we are very close to getting out of the cave, only if we use the fundamental truths of physics. We're at the limits. We could get smaller. We could get larger energy reactions. So we're not done in terms of more observations, in terms of more data, but we are done in terms of we know how a proton is composed of. We know how the close fundamental first quarks are composed of. So we know fundamental information, at least for these near field and near reactions, which is good enough. Surprisingly, a lot of the world is just encoded in protons, neutrons, and electrons. Who would have thought? Chemistry is true. Who would have thought? It's pretty cool. But whether people are out of the cave is up to them. Whether they know particle physics is up to them. So, kind of random. Do you have any thoughts regarding? Okay, that's the Plato's cave one. But does anyone that tells you they know how the universe works for sure is a liar? Dang, my lips are so chapped. That's terrible. But anyone tells you they know how the universe works for sure is a liar. I mean, you can do a lot with simulations of like electrodynamics and relativity, and that's all it is. So how the universe works, you're right, is not contained by any one person, but it is contained in the solutions of Maxwell's equations, general relativity, and particle physics combined. How do you think they came up with the concept of strange stars? Because they did the math and the computation and the electromagnetic interaction of strange strange matter stars. And they theoretically could exist, which is pretty cool. They theoretically could exist. Do they exist? That's more of a question. Well, according to the theory, the gravitational potential, even though they are trying to decay, their decay products will go back into themselves and then sustain it. So like they're going to stay strange. They're not going to change. Pretty cool. There's only one universe. I don't think so. I think there's infinitely many because, okay, I really don't put that's a really fascinating thing. Like, is there only one? In terms of the Standard Model, we know that there's only one of ours, and we know that it can't be simulated in terms of like just, what I'm trying to say that the reason why it can't be simulated is precisely related to the depth of these particle reactions. I explained it once before on a previous live, but I was much more decoherent at that time. So there is proof why we cannot simulate the universe, or why the universe cannot be simulated. So we're certain that we're in a real universe only because of our observations of actual quantum experiments. So we're still valid that you cannot simulate reality. Thankfully, no matter how many bits or whatever the heck, you still can't. It would be infinitely recursive. So what's good is the Standard Model shows that because the universe itself currently is infinitely recursive, it simulates itself. It does its own simulation, which is cool. I can't prove another universe. They say maybe through gravitational wave detection. Yes, Yes, that's actually one of the biggest amazing things that potentially. But here's also another reason why, even if we now have gravitational waves, like the impact of universes touching each other's borders, like if like that probably already happened, like maybe it already happened, like, and we just, the reason we're not detecting it is because it already happened. Because if we wait until we do detect it, and then it's a big enough wave where it's like, because you don't get it, this would have to be the mass of quadrillion, like tons of mass, and at that point those waves would be on the order of like probably like attosecond or atto like wavelength. So instead of nanometer wavelength, it might be atto wavelength. So it'll be like, these are relatively huge propagations through space, and at that point it'd be kind of cool. It'd be cool to basically say like everything shrunk and expanded in that small amount of distance due to that wave, that'd be more cool. It'd be like, did you feel the really big gravitational wave? And then relative to us, no, but like on like light experiments, theoretically that could have messed them up. But we're not doing tons of precision experiments to that degree to even care that such an event would occur. I'm saying it's not dangerous for us to have a gravitational wave would go through us, which is kind of sad. Like, I wish gravitational waves were way more destructive. That would be cool as heck. Imagine you could see it and you can feel it, like all our atoms get like crunched and then expanded. I personally would love to know that exists, but that only exists like really close to a black hole, and then like it's got to be orbiting really fast, and then you got to be right on the event horizon. So it's like, otherwise they expand out and they become like meter long wavelengths and even way longer. Like, so like you're not gonna feel it at all. What do you know about Earth's magnetic fields? The strength is actually very weak, so I know general information about it. The strength is like, I think 1/1,000 Tesla. They're very weak. And when NASA tried to do an experiment of harnessing Earth's magnetic field to generate electricity, it generated more than they were prepared for. So they built, if you know about Kirchhoff's loop law or even Ampere's law, if you have a loop of wire, it doesn't matter, a loop of wire, and you move it through a magnetic field, you now have flux through that magnetic field, change in field strength. So they were orbiting the Earth on the space shuttle. They unleashed a tether, but it shorted. It was too much current through that tether, and it melted off the space shuttle, which is fascinating. They weren't prepared for how much current was going to go through the wire at any point. So I really wish, and the thing about it is, I don't think they published, because I tried looking it up, how much voltage was generated. I don't think they published that. And maybe they did it because it might not be a good idea to use the Earth's magnetic field to generate electricity. Even though it might be cool to do, it might not be a good idea, because maybe we're gonna, deteriorate the magnetic field very slightly. Because every time you have flux and you're trying to use electricity, the electromagnetic forces are real forces. So if we generate electricity going in this direction, that direction, then Ampere's loop law, you're going to generate a force in the other direction. It's going to slow you down. So it might be a good way to deorbit spacecraft and generate electricity, but I think the voltage was on the order of 500 volts, but I don't remember. I can't find any specific studies, either 24 volts or 500. I don't remember. I tried looking it up. I don't think I found a definitive answer on how much shorted that wire. But you can learn about it on Walter Lewin, because he talked about that exact example, and that's what made me look it up. I was like, did they? And they did. So pretty cool experiment. Another universe outside ours, cone of causality. That's possible. Something from nothing always triumphs. Something only from the fundamental information of the standard model. That's all you need. All you need is binary itself. Honestly, it turtles all the way down, and time is a flat circle. It's also tiresome. It is also tiresome. Gödel's incompleteness theorem implies we can't really escape the cave. Okay. You're right. But it also, Gödel's incompleteness theorem doesn't apply for a physical world. It basically says that you need outside information in order to complete, to escape the cave, to complete your formalism. So Gödel's incompleteness theorem shows that math alone, formalism alone, cannot complete anything, or an entire set of knowledge, a set of basis. But using outside and categorizational values, you can learn a fundamental structure. That's what I think it means. We need to use observation and rigorous mathematical theory to basically say, now we are complete. If you try to, because you're trying to Gödel you're trying to, okay, just because we solve that doesn't, then this, like then it won't be solved later. And like, okay, I think we have Gödel's incompleteness theorem solved for physical reality. I think we have observation. We have observational physics. Gödel's incompleteness theorem applies when there's no observations. That's the only limit. It's like for black holes, Gödel's incompleteness theorem. For observations of the outside of the universe, Gödel's incompleteness theorem. That's correct. That's true. But for observations within the bounds of what we can observe, Gödel's incompleteness theorem doesn't apply, which is pretty cool. I think that's what it suggests. The cave would be sealed. If this is running on a computer, we will never see the electrical components. The cave could be sealed. So yes, you're right. Gödel's incompleteness theorem could apply, and it does apply on boundaries. We have an idea of how it works, but there are things the standard model can't explain. There are things the standard model is missing, and that's what I think I have shown that we can, and all we need is just that slight tweak. And I'm working on it now. I'm working on it again with the omega particle and other stuff. So I'm trying to go back to it, but I think the standard model repeats. I don't think they're going to find another quark above the top quark, and if they do, it's going to be their own formalism. I don't think it has to exist. As far as I have seen, in terms of the rules of parity, the rules of what's called Pauli's exclusion principle, pretty much binary rules is what it is. We're pretty profound that how the only way you can arrange two sets or four sets of two is 8 ways. So we have neutrinos, which are pretty much the other types of quarks, or a special type of quarks. We have the charm, strange, and we have the top and bottom. So we have 8. We have the 8, the fundamental 8, the ways you can arrange 2 sets of 4 or 4 sets of 2, something like that. So we have it already. So we're pretty much, I think we're done. So I'd love to read more about if we do discover something higher than the top, but I don't think there will. Math suggests a lot of things that might exist. Math has it. Oh, dang, I'm not trying to invite people, dude. I'm not trying to invite people. I'm just trying to read the comments. It might be a universe that set up the action of the particles, but once that ends, this begins. Bro, that's so cool. Thoughts on multiverse theory? I think it does exist, but it really just has to do with quantum potential. So what's his name? Dr. Blitz talked about it in a pretty good way. I do agree that it's pretty much just the wave function collapse, but it's what the wave function was. It's where it could have been at any such point in time. Multiverse theory sort of explains where we are right now. We are the expectation value of where we were supposed to be, where we were expected to be. So you right now, where we're all right now, we all are tied together in our own causal probabilities, and we are macroscopic. But we do have some phenomenon that gives us free will, or almost free will. Obviously, your current trajectory through time led you here. Your whatever inclinations, that is part of why people think there is no free will. But when we reach the scalar field, that when time progresses at 1 second per second, I believe we are traveling, at least you're right, there's still no free will, so to speak, but it's weird. When we're generating ideas, so it's like when we're in conversation, there is none, because you have to have a trajectory. But when you're in your own thoughts, your own thinking, you're free to supplant, to change your bit values at any time. And that's the closest you'll ever have to non-determinism, when we're thinking, when we're alone. Or even when you're thinking, when you're not speaking. If the universe is larger than ours and it runs into us, well, that would do damage. That's what we talked about with the gravitational wave. Some hippie is trying to surf the big G wave. That would be awesome. I heard a black hole doesn't have a center. Is that true? The reason it doesn't have a center is because it's a mathematical trick. It's basically if it did have a center or any amount of mass, so to speak, a mass object, if it had any object within it, then that object could not be integrated, or at least it would not have a correct integral. So for that reason alone, though black holes have mass, their mass is only written as a boundary condition of what's happening. It is not written as an integral of some object within there. Because once an object is in a black hole, what's cool about that is like, if we knew there was a maximum amount of mass per unit space, per distance, volume, then it would have an object. It would have a center. But because there is no formalism, there is not enough observable evidence to measure the event horizon accurately to a mass ratio. That's why we cannot say there's a maximum amount of mass in the center of the black hole. We know there's a maximum amount of mass, the source child radius, before an object becomes a black hole. So we know that has a maximum, but we don't know what the maximum is of the dense matter inside a black hole is. You get me? So because there's no maximum for that, there is no center. There's no mathematical trick for the center. So they don't even discuss it. If once again, Gödel's incompleteness theorem, if there's no way to measure it, there's no way to do it, it's sort of like, it's not Gödel's. Now we go to the what's it called? The holographic principle. If there's no way to go into the edge, it doesn't matter. What matters only is the outside, the boundary of the surface. And that's part of information. So holographic principle applies to conversation as well. It doesn't matter what I thought about and everything that it took, all the experiences I had in order for me to come to these ideas. It doesn't matter. What matters is the surface, the holographic principle, what we're talking about right now. It applies to everything. Do you care about what the center of my conversation is? You don't. You care about the surface of it, the holographic principle. Volts without amps is kind of useless, but not totally, but basically. Exactly, yeah, volts without amps is useless. Well, exactly, that you're right, that not totally. So volts, if you knew the resistance, you could find the amps. But if they tell you they had this volts on just a straight wire, then it's like, well, what was the ohms inside the wire? Was it standard 2 ohm at most, or was it less than 2 ohms? And so was it closer to like 0.8? The wire tested at 0.8 ohms per whatever length, or per the whole length, So was the wire standard? Was the wire not standard? Was the wire set to 10 ohms resistance? Like, what was the wire set to? So then you can calculate the current. But yeah, I agree. Dark energy and black swan events mean there could be a mass flip of physics. How would we know if everything in the universe was in one spot where it would be? Dark energy and black swan events mean there could be a mass flip in physics. How would we know if everything in the universe was in one spot where it would be? That's a good point. You wouldn't know. What I'm trying to say by that is that you would only have Maxwell's equations and what we already have available to us. So by what we have available to us, you couldn't know. Yes, some things, Gödel's incompleteness theorem, can only be solved if you can see it, if you can get that additional information, because our theory does not suggest that these should or would occur. There's no reason for us to predict that. Hey, this might occur, but that's where the next branch of information theory will get us to making new predictions. Once we build the information cascade up to the very, very black swan events of the standard model, we might be able to predict, like, hey, based on these gravitational patterns, there should be some system that has these black swan characteristics. That might be possible. But they're also extremely rare. So that system should decay almost immediately. So it's stuff like that where, like, we're going to go both ways. I think the standard model is going to let us go both ways in how we understand the astronomical phenomenon. The reason it goes both ways is because it already does go both ways. astrophysicists are supposed to know how to use the standard model in order to build physical models of planets and stuff like that. If you read something you remember, you do not. Truth matters. Non-determinism is a weird concept. We are stranded on an island of ignorance, and it was not meant that we travel far. Statistical predictions are as good as the weatherman rumor has it that he's not right often. Indeed, statistical predictions. If the study of statistics is very good, and that's what astronomy is based on. We use observations. We observe this number of stars, and that's why we say these are a categorization of stars. By using the Six Sigma method of determining what's an actual statistical event, and Poisson distributions, but discrete events, they have been able to detect real. So that's part of the discussion of philosophy, of how can math prove things? How can math prove that categories of objects exist? Objects are just groups and things and families and trees. You get me? Then they start saying there's no such way you can describe an object mathematically. There is, and that's what we do in astronomy. We use statistical mechanics to basically say, or statistics. You basically say okay, we look at these objects, we don't define them yet. We look at these objects, we look at them compared to other objects, and then we define the probability of them. You basically say, are these discrete? Are they their own category of things? Are there a finite number of these things? And by doing that, you're like, oh, these are and indeed a new class of object. Let's study them. Let's determine what they are. So stars that have iron in their cores, iron in their radiation, in their what's it called, their light patterns. So it's when you find a discrete object, a discrete event, you call it a new object. Philosophy really doesn't work in the actual scientific world anymore. That's why I think whenever philosophers try to say but can science describe a tiger versus a lion? Oh yes, of course we can. It's much easier to describe a red giant compared to a white dwarf by its electromagnetic wave. Its field, not field. It's emission spectra. Spectra. But we could do the same with a lion using statistical mechanics the exact same way. Philosophy sort of has no point in a modern educated society. Average math in first grade. Lamau, absolutely. It is indeed almost 1:40, and I said I was going to shut it down at 1:40. I had a wonderful time with you guys. Any last questions, Q&A? I'm going to shut this down at 1:40. I'm tired. I talked about what I want to talk about in the earlier live. The earlier live is going to be a lot more energetic, and it's going to be uploaded on Monday when I'm at work. Just let it run in the background. I do not want to stay here and wait for it to be processed and then download and then upload to YouTube. I can do it in the background while I'm working at my desk at work. So it's all right, tap these buttons, let it do what it's going to do. Work 15 minutes, come back, all right, press a button. That's what I can do. So these are going to get uploaded on Monday. Any questions? What do you guys feel? How do you guys feel about life? Do you guys feel safe? Do you guys feel comfortable? Do you guys feel okay? Do you guys all I want to do is just share how to solve problems for my friends and family. So people that I love and my future children. And I did that in the other live. This one is a lot more calm and my eyes are dry. So I got to deal with the physical world again. As soon as this live is over, I got to go on and I got to live. I got to solve problems, in my own life and stuff. So I got to use CPT symmetry and basically be all right, I'm detecting an event. My eyes are dry. That means I need to get quantized. I need to get water. And then how do I get water? I got to fill up the water bottle, go to the water station, fill it up, drink some water, wait a little bit so my body can process that. Delta T, oh my God. Drink more water. So it's just a process. I feel good. Vitamin A makes your eyes dry. Interesting. Interesting. Whatever. One more minute, and then we shut it down. How are you guys? Any thoughts? last thoughts? I love everybody. You know, you guys actually. I don't know why I got more likes on this one. This is a lot more quiet. Not really a performative show. So maybe people just happen to be off work or stuff. You know, I love you all. You guys are wonderful human beings. I hope everyone can have peace in their world, and they don't have to worry about stress, work, and deal with problems and things. So good on you guys. Good on you guys. All right, here's 140. I'll give you a bow, and then we'll shut it down. Thank you very much. Thank you for being here. I'll post this on Monday.